Hey students, this is Mr. Bornheimer, and this is going to be a video for my pre-algebra students. And in this, we're going to be beginning Unit 7, dealing primarily with geometry. Oh, I love geometry. Now, this particular lesson focuses primarily on 7-1, which deals with angles. And oh, what a great topic this really is. Okay, angles. Now, angles are so important to our understanding of geometry because every geometric shape except the circle deals with angles. We have to know the types of angles we're looking at. We have to know some of the notation so that when your teachers are talking about measures and congruent and ABC and vertices and like, what? Okay, they're dealing with all these terms. You know what they're talking about. So let's go ahead and get started with some of the basics. We are going to be looking in this video at several different vocabulary terms. The terms that we're going to be focused on primarily are going to be here on the screen in red, and they are right angles, something called supplementary angles, we're going to be dealing with complementary angles, vertical angles, we're going to be dealing with adjacent angles. I'm trying to think here. And actually, this doesn't necessarily fall into lines, more along the lines of right angles, but perpendicular lines. Okay, these are some of the main ideas that we're going to be looking at in this unit. Okay, so each one really has some important features to it in not only labeling and things like that. So that's what we're going to start with here today. Okay, so let's move on. And kind of disappeared there for a minute. Okay, let's move on. The first things first, we are going to go ahead and look at supplementary angles. Okay, so if you have a pen or pencil and you're watching this, it'd probably be very useful for you to actually draw these diagrams along with me because all of these definitions of these terms and what they mean are actually diagram heavy. Okay, so here we go. Let's go ahead and draw a straight line across the screen. There it is. Just so you all know, I'm using the app called GoodNotes. I'm going to kind of make a little note of that here in the bottom. And it has some great features for drawing, including automatic line adjustment, as you kind of saw there. So if you're looking for a good note-taking app, you can find this in the App Store. It is a little bit of money, but it's well worth it. Okay? So this is a line, and I'm going to call this line M. Okay? So that's what this is. This line M. And if I were to actually write this in terms of a notation, this would be M, and I'd put a little line symbol above it. And so that's line M that we're dealing with. And on line M, I'm going to put a point which I'm going to call X. Okay, that is point X. Over on the left-hand side, I'm going to put point A. And over on the right-hand side, I'm going to put point D. And I'm purposefully not using letters that come after each other in the alphabet. That's just a preference I have. So now, this, believe it or not, is an angle. Okay? This, what we're looking at here is angle AXD. Okay? Notice that the point in the middle, okay, comes in the middle of the naming of these letters. We call that middle letter the vertex, and it's represented by the point where the two pieces of the angle hinge. Okay? Now, any angle that is completely flat, horizontal, okay, is said to have how many degrees do you think? So right now, kind of make a guess. Okay? How many total degrees is that distance right there? And I'll give you a hint. It's half of a circle. It's a semicircle. And we would say that it is 180 degrees. Okay? So a straight line, a flat line, is 180 degrees. However, sometimes our angles get cut by rays. Now that there is called a ray because it starts at X and goes outward. And on this, I'm going to put the point B. Okay. Now I've just introduced two more angles. Okay. I've introduced angle AXB. Okay. Notice that that would be, and let me trace that for you. That is angle AXB. Okay, I'm actually going to also call that angle 1. So I'm going to say that that can also be or is congruent to angle 1. So they're kind of like the same. And then there's also angle BXD. Okay, so I'm going to write that angle BXD. And I'm going to call that angle 2. And I'm going to say that that one's congruent to angle 2. Notice again that X here is right in the middle. Okay, it's where the angles hinge. Okay, it's the vertex. And it always comes in the middle of our naming of our angles. Okay, so I've named these angles. I need to give myself a little bit of room here. I am going to put the word vertex next to X so that we don't forget it. But we need to get back to this important idea, and that is, what if I were to add the measure of angle 1? So this distance right here, and I were to add the measure of angle 2. So I were to add the measure of angle 1 and the measure of angle 2. Okay, what that looks like is that I'm adding the measure of angle 1 plus the measure of angle 2. And we see that if I go all the way from here to here, that is 180 degrees. That is that straight line measure of 180 degrees. So I can say that these two angles add up to 180 degrees. Notice that I included the M on these measurements. And you'll see that it kind of disappeared there because I'm changing the color a little bit. So that one's green, and I'm going to make this one blue to match. Okay, so the green angle plus the blue angle, or the angle 1 plus angle 2, when added together, equals 180 degrees. And when we're dealing with adding measurements, we have little m's here that represent the measure. So when we're dealing with numbers, not just naming the objects like AXB or angle 1, but when we're actually dealing with their degree measurement, like 180 degrees or 90 degrees or 33 degrees, we use this little letter M for measure. Okay? So supplementary angles are angles that when add up to 180 degrees. Okay, so that's supplementary angles. Now, now we're going to deal with complementary angles. And complementary angles are going to have a diagram all of their own. I'm going to go ahead and draw a straight line. And then I'm going to draw another line right down the middle here. Just like so. Okay. Then I'm going to draw a line out like that. Like so. This here, okay, is what we call a right angle. And right angles are formed, the little angle symbol here for right angles. Right angles are formed when lines that are perpendicular come together. Okay, so this is a right angle. This is a right angle. And there would be a right angle here too, but it's kind of being divided up. So we're going to come to that in just a minute. What we know about right angles is that they add up to 90 degrees. So I know that this is 90 degrees because it's a right angle. I know that this is 90 degrees because it's a right angle. And I know that this is 90 degrees because it's a right angle. Now, we can see that the two bottom angles, I will call this angle 1. I will call this angle 2. I will call this angle 3. I will call this angle 4. And I will call this angle 5. Okay? We can see that angles 1 and 2, if you were to add them up, would be supplementary because they add up to 180. And we see that angles 2 and 3, when added up, would also be 90 plus 90, or 180. So they would be supplementary. But then we have 4 and 5. And we see that 4 and 5 do not add up to 180. As a matter of fact, the only degree measurements that are left are those that add up to 90. Okay? So what we see happening is if we were to take angle 4 and we were to add to it angle 5, okay, that those two angles, when they come together, equal 90 degrees. So we would say that the measure of angle 4 plus the measure of angle 5 would equal 90 degrees. This relationship has got a special name, and it's called complementary. So these are complementary angles. Angle 4 here and angle 5 here. Because when you add them up, they equal 90 degrees. Now, there's a couple easy ways to try to remember complementaries and supplementary angles. Complementary angles always add up to 90 degrees. And supplementary angles add up to 180 degrees. And the way that I remember them is I remember that C comes before S, as does 90 before 180. So C comes first in the alphabet, 90 comes first if you were to count your numbers. S comes later in the alphabet, 180 comes later if you were counting numbers. So complementary angles add up to a smaller value, 90. Supplementary angles add up to a larger value, 180. Okay, so that's kind of how I remember this idea. Okay, so something to kind of keep in mind. Now, we also have some other types of angles. If you recall, we were dealing with right angles, which we've talked about, supplementary angles, complementary angles, but we also had things called vertical angles. So if you would, on your paper, draw two lines that crisscross like this. They do not need to be perpendicular. They probably shouldn't for this example. Okay, I'm going to call this line X, and I'm going to call this line Y. And what I'm going to say is that line X intersects line Y. That means that they are crisscrossing one another. Now, if you look at this carefully, it kind of looks like you have a V meeting another upside down V. This angle here and this angle here are what we call vertical angles. And what that means is that they are exactly the same as far as their measurement goes. So if I were to give these names 1 and 2, we would say that the measurement of angle 1 is equal to the measurement of angle 2. And when you have two angles that have the same exact measurement, they are called congruent. Okay? So this is almost like the definition of congruent is when they have the exact same measurements. So we would say angle 1 is congruent to angle 2. A way that we could write this is that angle 1 is weird squiggly, is congruent to angle 2. This little symbol, which you're going to see highlighted in purple, means congruent. Okay? So angle 1 is congruent to angle 2 because when you have two lines that crisscross, the angles opposite each other are vertical angles. There are two more angles here, though. We'll call this one 3 and we'll call this one 4. And 3 and 4 are also vertical angles. So let's go ahead and highlight those. These are also vertical angles because they are opposite one another. Okay, and so 3 and 4 would have the same measure, like right here, and therefore they would be congruent as well, which means that they're exactly the same. They're just in different locations. So these are called vertical angles. Okay, last but not least, and we can actually use this anytime two angles are right next to each other. They are what we call adjacent angles. So actually, I will draw a new diagram for this. And this doesn't have any particular rules. Let's make that a little bit better. Oh man, having a hard time here. Let's go with, there we go. Okay, I am actually going to use the naming scheme. Okay, I'm going to put an A here, an X here, a Z here, and an R here. Notice that these two angles, angle XAR and angle RAZ, not only share the same vertices or vertex, but they are right next to each other. They share this particular side. They share it. They're neighbors. They're right next to each other. And when you have angles that are right next to each other, you have angles that are known as adjacent angles. Now, angles can have more than one thing that they fall under. For instance, angles 1 and 4 are adjacent. And they're also supplementary because when added up, they equal 180 degrees. Angles 1 and 3 are the same way. Notice also that angles 4 and 5 are complementary, but they're also adjacent angles because they're right next to each other and they share a side. And if we go back to our original diagram, 1 and 2 are adjacent angles, but they're also supplementary angles. So we have all of these angles that can fall into multiple categories. So we're going to do one more diagram. We're just going to pick out some of these similarities like this. Okay, first of all, let's go ahead and identify some of the pieces that we do know. Okay, we know that angles next to each other are adjacent. I'm going to go through and number these. So we have angle 1, 2, 2, 3, 4, and 5. Well, I could say that angles 1 and 5 are adjacent. They're right next to each other. 5 and 4 are adjacent. 4 and 3 are adjacent. 2 and 3 are adjacent. Okay? I can also say that angles 1, 2, and 3 are right angles because of the little symbol there. Because 1 and 2 are right next to each other, and when added up, they equal 180 degrees, they're also they're supplementary. Angles 5 and 4, because they're right next to each other, and when they are added equal 90 degrees, they are complementary. And if you look, angles 1 and 3 are right across from each other. So they're vertical angles. So we have all of these angles inside these diagrams. And over the next couple of weeks, you're going to be asked to identify them in increasingly more complicated diagrams. However, with practice, you won't struggle with this at all. Okay? So this is a brief introduction, to angles. Okay? If you have any questions, you can obviously contact me by using my website, bclassroom.com. I hope you have a great night, and thanks for watching.